Okay, so this is your problem on Newton's second law of we're trying to figure out specifically this. When a water balloon was launched with a giant slingshot, it accelerated from zero point 0.0 meters per second to 3.50 meters per second in 0.48 seconds. When launched, the slingshot exerted a net force of 22.0 newtons in the x direction. What is the mass in kilograms of the water balloon? And in this problem, we are going to ignore air resistance. Then, afterwards, we are going to determine what is the weight in newtons of the water balloon. So it is a two-part problem. So let's start out with the first part of it always starts out of, once again, with second law problems, you want to draw a free body diagram. Then you go and you solve for the net force. Afterwards, you solve for your own equation. And finally, you just solve the problem. So what we want to do is free body diagram first of a slingshot and a water balloon. So with a free body diagram, what I am going to do is that I'm going to start with a dot. I'm going to put force of gravity going downwards. And then I have to think of the other forces that are acting upon it. What's going to end up happening is that you think, okay, slingshot. Well, you could say applied, and I would be perfectly okay with that, but you don't have the opportunity to use force of tension enough, and it's more fun to use different forces. So I'm going to say that force of tension is acting into the rightwards direction. Now, there is nothing going upwards, and there is nothing going to the left because we are ignoring air resistance. So this is the only two for your free body diagram. Done. Now let's solve for the net force in this problem. And for the net force, what we want to do is that we add together all of the forces, but much like the first problem, that our force of gravity is going to be negative and our force of tension is going to be positive because of the Cartesian plane of saying that upwards is positive, to the right is positive, downwards is negative, to the left is negative. Same thing as like an XY coordinate system. So I'm going to put that my net force is equal to negative force of gravity plus force of tension. Okay, so net force, check, done, and now we have to do our own equation. So for our own equation, what we are going to write is we always start out with Newton's second law. Net force is equal to mass times acceleration. And I'm going to plug in for our net force. Negative force of gravity plus force of tension is equal to mass multiplied by acceleration. Now the issue here is that by itself this doesn't look too terrible, too terrifying. However, your next thing, if that's your equation, would be to solve. And we're trying to solve first for the mass in kilograms. So we have to know everything else, the acceleration, the force of tension, and the force of gravity. Well, there's an issue here. Force of gravity is always the mass multiplied by the acceleration of gravity. If we don't know the mass, we can't solve for the force of gravity. And then you start talking about acceleration. Well, is the acceleration due to the force of tension or is it due to the force of gravity? So right now, our own equation is not able to be used to solve it. This guy down at the bottom is a no-go. I'm actually going to cheat a little bit. And in order to cheat a little bit, what I'm going to do is I'm going to divide up my two coordinates, saying that I am first going to do all of the forces acting in the x direction, and then I am going to do all the forces acting in the y direction. So I'm going to write that the net force in the x direction is equal to, and the only force acting in the x direction is force of tension. So I write force of tension. And the net force acting in the y direction is equal to my negative force of gravity. So I write negative force of gravity. Now once again, this is fine of I'm breaking everything up, but I have to break up Newton's second law as well of net force in the x direction is equal to mass multiplied by the acceleration in the x direction. and the net force in the y direction is equal to mass multiplied by acceleration in the y direction. Now, the reason why I'm doing this is that forces and acceleration are vectors, that they both have to have a direction associated with them, while mass is only a scalar, meaning that there is no direction. I don't have to have the mass in the y and mass in the x. It literally is just as is. So now I have my net force. I have my net forces here. I'm once again going to do a substitution of net force in the x is force of tension is equal to mass multiplied by the acceleration in the x direction. And in the y, I have negative force of gravity is equal to the mass multiplied by the acceleration in the y. So these now are my two equations that I am going to use for the remainder of the problem. Own equation, check. Now finally, the last thing that we have to do is we have to solve. And to solve, I'm trying to find out mass. So to solve for mass, I have to either know my force of gravity or I have to know my force of tension. In the problem, it states that when launched, the slingshot exerted a net force of 22.0 newtons in the x direction, meaning that I am only wanting the x direction right here of I have to use this problem in order to solve, meaning that this is the problem that I am going to use. So force of tension is equal to mass multiplied by acceleration in the x direction. And I start plugging in my known and unknowns. Force of tension is that 22.0 newtons. My mass is my unknown. And the acceleration in the x direction should be something in meters per second squared. Now, if you look over this problem once again, there is nothing in meters per second squared. So that means that you have an unknown. However, it's a little bit simpler than that. And in order to make it a little bit simpler, what we have to do is that we have to solve for either mass or the acceleration in the x. We can't solve for mass, so we have to solve for the acceleration in the x direction. So what we do is that acceleration in the x is just an acceleration problem. Vf minus vi divided by the time. And this is where I start out. Once again, knowns and unknowns. Velocity final should be that 3.50 meters per second. That the velocity initial is that 0 meters per second. And the time is equal to 0.48 seconds. Now I have an acceleration problem. Easy enough, not too bad. I don't have to rearrange. There's no VF, there's no VI. I just plug in. So acceleration in the x is equal to 3.50 meters per second minus 0 meters per second divided by the entire thing is 0.48 seconds. And you should get an answer that is equal to 7.2916, but with sig figs, I have 2 sig figs in this problem. I need to have 7.3 meters per second squared is the acceleration in my x direction. So acceleration in the x. Now I just use this value down here and I plug it in now I'm trying to solve for mass. I need to rearrange this equation, force of tension is equal to mass multiplied by the acceleration in x for mass. And to do that, I am going to divide both sides by the acceleration in the x direction. Force of tension is equal to mass divided by acceleration in the x direction. Force of, my bad. I have mass is equal to force of tension divided by the acceleration in the x direction. There we go, much easier. That way, all we have to do is plug in, so mass is equal to force of tension, that 22.0 newtons, and my acceleration in the x direction is what we just calculated, is 7.3 meters per second squared. And you should get a mass of, it's like 3.0 4, something like that, but you need 2 sig figs from the 7.3. So you are going to get a mass of 3.0 kilograms. So that is the answer of the first problem. Now, we have a mass, and with that mass, what we want to do is we want to now solve for the second part of the problem, the weight of the water balloon in newtons. So to solve for the weight of the water balloon, remember that weight is just force of gravity. No matter what you're doing, it's always force of gravity. Anywhere in this problem that says force of gravity, we can use as the weight. So what we have is we have a force of gravity right here, and that is what my equation is that I'm going to use in my problem. So negative force of gravity is equal to mass multiplied by the acceleration in the y. Well, this is my unknown, and I'm not going to write negative just because it doesn't have like the negative with the variable. The negative just is before. So force of gravity is my unknown, that my mass I just solved as 3.0 kilograms. And the acceleration of the y, you want to be very, very careful here. This is acceleration of the x, not in the y direction. Acceleration in the y is due to the only force that is accelerating in the y direction. And the only force that is in our y direction is force of gravity, meaning that the acceleration of the y is my force of gravity's acceleration. And you know the acceleration of gravity as negative 9.8 meters per second squared. Now, we have used both positive and negative 9.8 meters per second squared, and you might ask, well, Mr. Tate, why is it negative here? The entire reason why is because, once again, acceleration is a vector, and in this specific problem, that vector is moving in the downwards direction, meaning that it is negative. So I have a mass, I have an acceleration in the y direction, and I just now need to plug it in. Force of gravity is equal to 3.0 kilograms multiplied by negative 9.8 meters per second squared. I have that, I plug it in, and I solve as a force of gravity, oh, mind you, this is negative, as should be 29.4 newtons. So I'm going to put negative force of gravity is 29.4 newtons, but I need 2 sig figs from the 3.0. So I have 29 newtons. Okay, which should make sense. Originally, once again, this is negative, and the negatives can cancel out or they cannot. I don't really mind. If you keep it like this, that's fine. If you write force of gravity is equal to 29 newtons, once again, that's fine. It's really not that large of a deal. So now let's take it a step forward. The only other thing is that let's now solve for the entire net force of my problem. So to do that, what I need to do is I need to say that the net force is equal to, and I'm going to go back to the way original. Net force is negative force of gravity plus force of tension. So my negative force of gravity is equal to negative 29 newtons, and my force of tension is this 22. So I am going to add 22 newtons to this negative 29. And you get a value of negative 7 newtons. And once again, we want to decide which direction. Well, the force of gravity is the one that is larger. It's the one that is contributing the most to the acceleration of this object. And the force of gravity is in the negative direction. And it is specifically in the y direction, meaning that we are going to write y hat, and that would be the end net force of this entire problem.